Okay, so section 4 is all about dot products. So when you're talking dot products, these are basically all the formulas or properties that you need to know. When you see the dot product, it's actually a bold circle. It's not the time symbol, okay? So it's actually bigger, fully closed in, kind of looks like a time symbol, is actually bigger. So dot product of two vectors, you do the first part in vector u, first part in vector v, multiply them together, second part's multiply them together, and you add. Dot products are always a number. A property, if you do the dot product with itself, it's actually the magnitude of that vector squared. And then this is your formula for the angle between vectors. The part that talks about is it orthogonal, parallel, or neither. If it's orthogonal, the dot product is 0. If you can take a number times another vector to get a vector, that is parallel. If it's neither one of these, then it's neither. And then we'll do projection. Projection of v onto u. This is your formula. So we talked about magnitude before. So today, the only thing new today would be the dot product, which are these full circles. You are going to be working backwards to find angles. So you're going to be using your cosine, which is when you're finding the angle, you're actually going to have to remember that you got to do inverses. Okay, so when you're doing those, make sure we have our calculator in degrees, and we're actually doing cosine inverses. Okay, so those are all your formulas that you need to know. So now we'll do some examples. Okay, so for the first part, we're just doing the dot product of u and v. So for the dot product, you do the first part of u, first part of v, multiplied together. So 6 times negative 2 plus, then you multiply the second parts together. 1 times 3. So 6 times negative 2 is negative 12. 1 times 3 is 3. Add those together, I get negative 9. Dot product is always a number. It's not a vector, it's just one single number. Okay, same thing on number 2. So I would take negative 4 times 2 plus 1 times negative 3. So I would have negative 8 minus 3. So my dot product would be negative 11. Okay, then you're going to have a part that you're going to have to find the magnitude. So with the section before, you found the magnitude after you found the vector. These are just going to be given the vector, whether it's in component form or if it's written as linear combination. So to find your magnitude, once it's in a vector, it's just the square root of each part squared, just like we've done before. So this part should not be anything new. So this would be the square root of 25 plus 144. Which is the square root of 169, which is 13. Okay, so that should not be anything new. Should be the same stuff that we've already done from the first section. Okay, so this is written as linear combination. So when I find the magnitude, it's the same thing. It's just the first number squared plus the second number squared, added together. So square root of 400 plus 625, square root of 1025. So it's not perfect, so if I break it down, 5, 205, 5 and 41. So my magnitude would be 5 square root of 41. Okay. All right, so we've done the dot product. Now we're going to move on to angles between vectors. So you're going to be given two vectors. This is your formula, so you're going to have to know the dot product, and you're going to have to find the magnitude of u and v before you can even worry about this formula. So if I want to find the dot product, so that would be 1 times 0 plus 0 times negative 2. So this is 0 plus 0, which is 0. Okay, then I need to know the magnitude of u. Magnitude of u is the square root of 1 squared plus 0 squared. Square root of 1, which is 1, not 0. And then if I find the magnitude of v, square root of 0 squared, excuse me, plus negative 2 squared would be square root of 4, which is 2. Okay, once you have all three of those, then I can put it in this formula. So this would be the cosine theta equals 0 over 1 times 2, which is 2. So 0 divided by 2 is 0. So I have the cosine equals 0. To find this answer, not that answer, to find theta, you're going to do cosine inverse of whatever number that is. So since I want to find theta, I'm going to do cosine inverse of 0, which that means that theta is going to be 90 degrees, because that's what I get when I do the cosine inverse. Where is cosine 0? Cosine is 0 at 90 degrees. So you find those three things, plug them in, and then you do cosine inverse of whatever that answer is that you get. If that's not perfect, you're just going to round to 2 decimal places, just like we would do on any other assignment. Okay? So if I do another example, so if I get to this one, do the dot product first. So this would be 2 times 6 plus negative 1 times 4. So this would be 12 minus 4, which is 8. Then I do magnitude of u. So that's the square root of 2 squared plus negative 1 squared, which would be the square root of 5. Okay, that doesn't reduce. You can't write that down, so you leave it like that. Then I have magnitude of v. So the square root of 6 squared plus 4 squared. So 36 plus 16 would be what? Square root of 52? So if I try to find, I want to find my angle, I have cosine equal to 8 divided by, okay, when I multiply those two together, you can just make that one square root. So if I take 5 times 52, what is that, 260? Now, I know this is not on my unit circle. So what I'm going to do is I'm going to figure out what this is right here, and then I'm going to do cosine inverse of that number to find what theta is. Okay, so if I do 8 divided by square, okay, and then I do cosine inverse, I get that my angle is equal to 60.26 degrees. Okay, so now we've done the dot product. We've done the angles between vectors. Then the next part we're going to find out whether or not it is parallel, orthogonal, or neither. So we're going to know if the dot product of 0 is orthogonal, if you can take a number times it to get the other vector, then parallel. If it's neither one of those things, then it would be neither. Okay, so we'll do 2 examples. Okay, so if it's parallel, that means I can take vector u times some number, and I'm going to get vector v. So let's say, how would I get from negative 12 times what number is going to give me a half? Okay, well, if I figure this out, I'm like, okay, well, if I divide by negative 12, that's by multiplying by negative 112. So I know that if I multiply by negative 1 over 24 times negative 12, that gives me a half. Okay, so then I see, does that work for the second number? Because it's going to work for the first one, it has to work for the second one. So if I take 30 times negative 1 over 24, well, if I multiply that through and I reduce, I have negative 30 over 24. Those are both divisible by 6. I get negative 5/4, which is what we wanted. So that means I multiplied by the same number. Since I did that, this is parallel. If it's not, then we would check orthogonal. Or you can check orthogonal first, it doesn't really matter. If it's neither one, then you know it's neither. So like if I go to number 8, let's say I want to check parallel. So I know I have a 2 here and I want to get a negative 1. So I'm like 2 times what number gives me negative 1? Well, if I divide by 2, that means it has to be negative a half. Okay, so I check to see, does negative 2 times negative a half, that gives me 1, which is non-negative 1. So I know this is not parallel. So I'm like, okay, not parallel, so now I'm going to check orthogonal. It's orthogonal if the dot product is 0. So I'm going to check that. So 2 times negative 1 plus negative 2 times negative 1. So this is negative 2 plus 2, which is 0. So since it's 0, that's orthogonal. If you check both, neither one work, then you would write neither. It cannot be more than one option. Those are your 3 options. Parallel, orthogonal, which also means perpendicular, or neither. So those are your 3 options it could be. Okay, then the last thing we're going to talk about is projection of u onto v. And you will not project the other way. So this is your only formula that you have to know for that part. You're not going to project the other way. Okay, so my answer on a projection is going to be a vector. How do I know it's going to be a vector? Because this is going to give me a number. Dot product gives me a number. That is a magnitude, which is a number, but then you're multiplying it by vector v. So this is a number that you're going to end up basically distributing. So I have to find the dot product of u and v, and I'm going to have to find the magnitude of v squared. Well, if you do the dot product with v itself, that is the magnitude squared. So that's why I wrote this property down there, because that kind of saves you a step from square rooting and then re-squaring. Okay? So first thing I'm going to do is find the dot product. So if I do the dot product, u and v, that would be 2 times 6 plus 2 times 1. So 12 plus 2, which is 14. Okay, then I want to find the magnitude of v squared. So that means I'm just going to do the dot product with v. So that would be 6 times 6 plus 1 times 1. So 36 plus 1, which is 37. So I have the dot product over magnitude of v squared. That goes on the outside, and all you do now is just multiply it with vector v. So that would be what? 84 over 37 and 14 over 37. And if you could reduce that, you would reduce it. Since that doesn't reduce, you would, and if you want to put this as a mixed number, you can, you don't have to. Okay. All right, those notes should be able to get you through everything on page 467. So then all we have left to do is page 478, which is section 6.5. And we'll cover 6.5 on Monday and probably Monday and Tuesday next week.